everyone, welcome back to my channel. I am Sakshi and here is the episode 8 of Learn DSC with Sakshi. Until now, we have been learning about the linked list as a part of the data structures, understanding how they work and how to manage data efficiently using them. In our previous video, we have already seen the theory behind the doubly linear linked list, where each node connects in both the forward and the backward directions. Now it's time to move to the implementation part and we see how its code work in actual C code. We'll begin with the basic operations like the insertion at the end and beginning and then move toward the deletion and position based insertion. So without wasting much more time, let's get started. So these are the topics which we are covering today. First, we will implement the doubly linear linked list in C, and then we will see the difference between the singly linear linked list and doubly linear linked list. So we'll write the code from scratch and understand it step by step. So let's move to the VS Code. So here is the program I shown you in the previous video. Now in the today's video, we will write it from the scratch so that you will understand it better. So let's make a new file, program13.c, and write the code from the scratch, from the starting. So include the header file. Then main function and return 0. And here we will write our further code. So first we will write our struct node, then its parameter integer data, then two pointers, one for the next and other for the previous. So write it as struct node star next and struct node star previous. In singly linked list, we use only the struct node next because it will move in only in forward direction. But in the doubly linear linked list, it will move in both the direction. So we include two pointers here. Then I'll comment it as star so that this is the new line which we add in the singly linear linked list. So this is only the new line. Then type def part. Type date struct node. It is as same as the previous one. Type date node start is p node and type date struct node star pick node. Then we will write our 8 function as we saw in the linear linked list, singly linear linked list. So first is the void insert first, and we will write its parameter afterwards. Now just we'll make a structure. Okay. Then firstly we will write all the 8 functions and then we will proceed it to further in details. Then void insert first, then insert last. Insert last. Then insert first, insert last. Void. Then void display. Then int count. Then we saw the delete part. So void delete first, then void delete last, then void insert at position, and then void delete at position. Insert at position. So these are the 8 functions. We create its structure here. Now we'll see its parameter one by one. So in the insert first, our parameter it will be same as the singly linear linked list. So it will be pp node head and integer number. Then in the insert last, it is also same as the insert first. So pp node head and int number. Then in display, we need only one parameter, that is p node head. Sorry, p node head. And then in the count function, it is also same as the display, so it requires only one parameter, that is the p node head. Then in the delete first function, then it only requires the pp node head and not required the int no, because we want to only delete that number. We don't take that number, so its parameter will be only pp node head. Then similarly for the delete class, pp node head, and then insert at position. For this, we will require pp node head, then int no and int I close position where we want to insert the new node. Then similarly for the delete last, pp node head and int I pose only, because same for the as we see for the delete last. So these are the parameters and the functions we write here. And now we will see its logic one by one. So let's start with the insert first logic. We will comparatively learn the doubly linear linked list with the singly linear linked list. So we will compare both the linked list and then write the code. So in singly linear linked list, the insert first function does the this is the core of the singly linear list. In singly, it does the new and next is equal to star head and star head equal to new n. But in the doubly linear linked list, we have to add 2 more steps. So what will be it? So let's first write this part. This will be same as the singly linear linked list, and then we will discuss this logic. So p node new n is equal to null. Then allocating memory new n. I will copy it. I just copy and paste it from the singly program, and we will make changes in the else part only. So it will take less time. So I just copy paste this part from the program number 10, and now we'll need to add here new and previous, because in doubly linear linked list there is 2 pointer, that is next and the previous. So previous also initialize it to null. So and in singly linear linked list the else part is different. So we will upgrade this part, and if star head equal to null, if there is no pointer, then make star head equal to new n. And in the else part, we need to update the head to the new node. So same as the singly linear linked list, but also update the previous of the old head to point to the new n. So new n next equal to star head, it remains as it is. Just we need to update the star head previous. Star head previous is equal to new n, and star head equal to new n as it is. So why extra pointer? Because in doubly linear linked list, the previous pointer of the head must be point to the new node. So that's why we are using it. So communicate as start, we add this line and this also. Then now same as the insert first, copy the logic of the insert last. and paste it in the InsertLast function. Right. So in similarly linear linked list, only the else part is different. We will traverse till last node and attach new node at the end by this part, right? But in the doubly linear linked list, we will implement the same logic but also set the new and previous equal to 10. So let's add this line. So here we need to add first previous pointer. So new and previous is equal to null. Hmm. New and previous is equal to null. Then if star head equal to null, if there is no new pointer or node, then make the star head as the new node. And in the else part, store the address of the head in the temporary pointer. Then this condition remain as it is. Just add the new and previous is equal to 10. So why new and previous? Because new and node should know whom its previous node is. So that's why we added. Now the display and count function remain as it is. We just need to upgrade this part. Means this is presentation of the singly linear linked list. Then we will change it. So copy this part. We'll see config. In doubly linear linked list, in the both end, we see null. So print one more statement here. Printf null. Then this. That's all. So this is about the printing part. Then while star head is not equal to null, then printf, just make it here this change, and head is equal to new and next, and that's it about the. So this is how we write the display function. Now let's move toward the count function. Now copy the logic of the count function and paste it in the program number 30. So here is the count function. So count function is same in both the linked list, traverse with the star head and then increment the counter. So we will not make any changes in the count function. It remains as it is. Now let's jump toward the delete first. So similarly, just copy this program and paste it here. Now in the singly linear linked list, we write that star head is equal to star head next, and then we will free the old head. Just update the head and then free the old node. But in the doubly linear linked list, after moving head forward, we also need to break the backward link. So for this, we need to write the extra logic here. So what will be these two lines here? So first it will temp equal to star head. We are storing uh, one second. Firstly, I'll explain all this logic. In the delete first, I'll take one temporary pointer and initialize it to null. Then I'll check it is empty or not. If it is empty, then simply return from it, because if there is no node, what's the point of deleting, right? Then we will check the next condition. If it contains only one node, then free that node and make star head equal to null. So it will delete the first node. And in the else part, if it is contain multiple nodes, then means if the linear linked list contains, let's say, three nodes, then how to delete the first. So this is the logic of here. So firstly, star head is equal to, so just delete this part and write star head is equal to star head next, and then free star head previous. We need to unlink it so that we are using free star head previous. So here it will take one bracket, right? And then head previous is equal to null. Star head previous is equal to null. So the extra step is free star head previous and make star head previous equal to null. Then why? Because to remove the back references from the new head. So that's why we add this new line. So both are, so just comment it as star, right? Then let's move toward the delete last. Copy this code. Yes. In delete last, we'll take first temp pointer and initialize it to null. Then similarly checking the three condition. If it is a null, then just simply return from the linked list. Then if it contain only one node, then just free that node which is the head and initialize it to then null. And in the else part, if it is contain multiple nodes, then how to delete the last node. So delete last logic is same as the singly linear linked list logic, but it is easier if you had a tail pointer. But as we are not going to use the tail pointer, let's understand this logic. Um, so doubly linear linked list allows deletion using the previous from the last node if needed. So it is same, just we need to traverse to the last second node and delete last. So for this, while temp next is not equal to null, then make temp equal to temp next. From this line, we reach the last second node and then free the temp next, means free the last node and make temp next equal to null. So this entire function is same as the program temp, no need to change this. So this is all about the delete last function of the doubly linear linked list. It is same as the previous one. Now let's move at the position based operation, that is the insert at position and delete at position. So let's see first the insert at position. Just copy this program until this and paste it in our program number 13. As you can see here in the singly linear linked list, we traverse to the position -1 node and then set the new and next is equal to temp next and set temp next equal to new n. Then in the doubly linear linked list, same as the singly linear linked list, we also handle both the forward and the backward links. So we need to add the extra step, and that will be adding the temps next previous is equal to new n and new n previous is equal to temp. So let's understand it from the starting. So we'll take two variables, first for the counting the total numbers of nodes in our linked list, and then one is for the incrementing. So taking two pointer here, new and temp, and both initialized to null. Then count now is equal to count of star head. So we are using this count function which we are declaring here. So we reuse this function and then we create one filter that is checking the position which we are going to give it is valid or not. So for this is the same filter as the previous one. Then checking the three condition, that is if the position is first, if the position is last, and if the position in between the nodes. So if the position is first, simply call the insert first function and it will do our rest part. Similarly, if the position is the last, means we have to insert at the last, just call the insert last function and it will insert at the last. But if we need to insert in between the positions, then firstly make new n, allocating memory to it, then its data and its data and next, and we need to also add its previous also. So previous is equal to null. Then storing the address of the star head in temp. Then for I is equal to 1, I is less than IPOS -1 and incrementing I plus plus. Then updating the temp as temp is equal to temps next. So until this it remains same. Then we just need to update this part. So new and next equal to temp next, it will remain same. Then we need to add temp next previous is equal to new n. So new and next is equal to temp next. It means new nodes next points to the current next. So this is for this line, and then temps next previous. Temps next previous is equal to new n. This means that the current next previous point to the new node. I know this is a bit confusing and you won't get it in the first attempt, but just make practice of it and you will get it. And we will saw its insert at position and delete at position diagram afterwards. So now just write this, then it will remain same. And this means the current node's next point to the new node. And then new and previous is equal to the 10. Yeah, means new node's previous point to the 10. So this is how we can go, go in both the forward and backward direction by adjusting these four pointers. So this is how insert at position works in the doubly linear linked list. Now here we add this line and this line. Just save the program. Now we are remaining with only one function and that is the delete at position. So firstly copy this code, insert here. Then our goal is to delete a node at the specific position. So first check if the position is valid or not. For this, use this filter. Then if position is first, then simply call the delete first. And if the position is last, then call the delete last. Else, traverse till the node just before the one to be deleted. Then use the temporary pointer target, that is target equal to target next, and then adjust the two leaves. This is how we can upgrade the delete last program. So here we make one target pointer, initialize it to node, and we will use it in our else part. So temp is equal to star head. Then for I is equal to 1 to I pose minus 1 and I plus plus, just upgrade temp to the temp next. Then target equal to temp next and temp next equal to target next. Then we need to add temp next previous is equal to temp. Temp next previous is equal to temp and free the target. Yeah, that's all about the delete at position. In delete at position, we no need to use the extra pointer like the previous manually, as in the singly linked list, because the previous pointer already exists. So temp next equal to target net, just simply skip the node. Then temp next previous equal to temp, it fixes the back pointer, and free target, it delete the required target net. So this is how about the delete at post. Now we completed all the 8 function. Now just call it from the main function. Or we can first draw the diagram of the insert and delete position, and then we will call it from the main function. So let's draw the diagram for it. I'll first draw the diagram and then explain to you. So this is the diagram of the doubly linear linked list, where head is pointed to first and first is pointed to the first node. That is, this is the previous, 11 is the data and 200 is the next. So here we have the linked list of the 4 nodes, and let's say we have to insert a new node at the 4th position. So it will be anywhere between this, right? So for this, let's move to our code, what it say. Insert first. So it will first the count node. So total number of nodes are 4, and we have to insert also at the 4th position. Then our position is valid because it is not less than 1 or not more than the count node plus 1. And it will not call this part because it is not at the first position or the last position. It is between the position. So it will call the insert in between the position. So for this, it will make new n, then allocates data, previous and null to it. So we have make it new n, it's previous, data and null, right? So firstly make previous and data equal to null. So right here null, and it is also null. And insert the data. Let's say I want to insert 75 here. 75 here. And it is between these two. So let's make its address as the 350. Right. And It is simply pointing to this. Right. Now temp equal to star head. So temp will take star head means 100. So it will take 100 first. So 100. Then for I equal to 1, I is less than I plus minus 1, I plus plus, then it will increment temp equal to temp next. So I is 1, then I is less than 3, and so I is less than 3, so it is inside the for loop, and then increment temp as equal to temp next. So temp next is equal to 200, right? So firstly, it will arrow toward this. Now, when I is equal to 2, so I is less than 3, so it will in the for loop, and then temp next, so it will point for 2, then 200, temp equal to temp next, it will update. Then I plus plus. Now I is 3. So when I is equal to 3, as we have to insert into fourth position, then it will point to the 300. When it will point to 300, this will go. This go to now temp will hold 300 as its address. So now this part is done. The work of for loop is complete here. Now this new and next equal to temp next. So new and next is equal to temp next. So now let's see this part. So this is our diagram. So first what it say that new and next is equal to temp next. It means so it will point to this. So our new and next. So this is the new and next. So it says that new and next is equal to temp next. Now our temp is 300. Temp next is 400. So it will point to, it will point like this. So this is for the first line. That is new and next is equal to temp next, right? Just then second line is temp next previous is equal to new and. It means that so temps next previous, so temp next previous is equal to new and. So this is how. So this both will go on, and this is the new linking part here, right? Now the third statement is temps next is equal to new n. So temps next is equal to new n. This will like this. Temp next is equal to temp next equal to new n, and new n previous equal to temp. So new n previous is equal to temp. It means it will new n previous is equal to temp. And in this way, this both link will go on, and then how our linked list flow will be. So first is 11, then 21, then 51, then 51 goes to 75, then 75 goes to 111 in this way. So this is how insert at position in between the nodes works. I hope I make you understand. So this is all about the insert at position. Now let's talk about the delete at position. I'm just updating this diagram. So just make a new diagram here. So here is the complete diagram for the delete at position. Then so first I count, it will take the count as we have 5 nodes. So I count is equal to 5. Then temp is equal to initially ignore, and target is also null. And then checking filter as we let's say we have to delete the fourth position, that 101 should be deleted. So fourth position node we have to delete, and then so this else part will work here. So firstly temp equal to star head. So temp is star head, so head is 50 and star head means 100. So it will take first 100. So it point toward the 100. right? It will point toward the 100. Now, when the for loop start, for I is equal to 1, I is less than, I pose is 4, 4 minus 1, 3, I is 1 is less than 3, so enter into the loop temp equal to temp next. So what is temp next? Temp next equal to 200, right? Then I plus plus, I becomes 2. 2, I is equal to 2, 2 is less than 3, so temp equal to temp next. So then it will point toward to 200. Similarly, I plus plus, and then at the end, I plus plus only, so it will be 300, right? So let's point toward the 300. Then this will remove. So now our temp become 300, right? And then target is equal to temp next. Temp is 300, temp next equal to 400. So target become 400. So just write 400 here. Then temp next equal to target next. So temp next is equal to 400, which is equal to, so temp next is equal to target next. This is temp and this is target. It is target. Then temps next previous is equal to temp. So this means temps next, that is target, and target previous is equal to this, right? Actually, this is wrong. This is wrong. And this temp next equal to target next means it will go from here to temps next equal to target next this, then temps next previous means from this to this. So, and then free the target. So just free it. So this is all about the delete at position. So I hope I'm able to understand this to you. So this is as simple as the singly linear linked list. You just need to understand the concept and then you will understand it. So this is all about the doubly linear linked list. So far we have completed two important topics. First is the singly linear linked list and second is the doubly linear linked list. We covered all basic operations like the insertion, deletion, display count along with the logic and differences. Now, if you're confident with these two, then it's time to level up and slightly explore the new advanced topics like the circular linked list. Yes, in the upcoming videos, we will be covering the circular linked list, two parts, that is the singly circular linked list and then the doubly circular linked list. So that's it for today. In the next video, we'll begin with the singly linear linked list. If you haven't already subscribed, make sure to like, subscribe, and turn on the bell icon so that you don't miss the next part. So that's all for today. Thank you for watching. See you in the next one.